Hello everyone, I'm Siddharth Mittal, currently pursuing a Bachelor's in Technology from Binit University, Greater Noida. And today I'll be talking about WebSockets. Today's world, we have dived really deep into various real-time applications. We are so used to getting the real-time updates on our fingertips. But do you know how it happens? Do you know what goes behind the scenes in these applications that we so casually use? If you have any familiarity with the way a conventional web request works, you know that real-time data is not really possible through them. It's just a normal HTTP request is just not made to do that. So how does it happen? It happens through WebSockets. Now let's take a look at the journey a web went through before we could get this ever updating data in real time on our fingertips. When the web was created using HTTP protocol, it made the interaction between the web and the user in four simple steps. Open a connection. The client sends a request to the server. Server collects the data and sends a response back to the client, and the connection is closed. Now, this worked well initially, letting two nodes communicate over the internet. And since it was stateless, even if the connection was for some reason dropped, we could easily just restore the communication from that very point. But this had a major flaw. From perspective of real-time data at least, the latency. Imagine we have to retrieve 10 different pieces of data. And to do that, you would have to open 10 separate connections, send 10 separate requests, and wait for 10 separate responses, and then close those connections. Seems a bit redundant and slow, to be very honest. But that's just how it worked back then. So what happened? That's when we were introduced to long polling. With long polling, the connection that was set up traditionally, the request response cycle, it persisted for a little longer. That is, the server had an opportunity to collect more data, more than a single piece of data, and send back in a single response. Now, this also eliminated the case where the server has to send empty responses, because the server could just wait before it has any update, send it back to the client. The request just stayed open. Now, to get those same 10 pieces of information, we would only need two connections, or maybe even one, depending on the size of the data that you want. Seems a bit fast. It is fast. But when you scale it to billions and billions of requests a day, the latency adds up. And it still doesn't give rise to real-time updates. It would be faster than a normal HTTP connection, yes, but it would still be slow enough that we cannot consider it a real time. That led to WebSockets. Now a socket starts as a normal HTTP request between the client and the server. But when both the parties agree to establish a socket, the connection is elevated to a TCP connection, which stays open for as long as one of the parties decides to terminate it. This allows for a bidirectional communication between the client and the server, which means that the server can simply send updates to the client whenever they are available, instead of waiting for a client to request an update. Now, we can clearly see that the WebSockets have an advantage over the HTTP connections. But does that mean we should just discard HTTP altogether? The answer is no. Just like any technology, both of these have their own use cases. Both of these have their own scenarios where they are better performing than the other. Let's take a look at few of them. Here are a few scenarios where HTTP is a better choice. Whenever the current state of a resource doesn't require ongoing updates. Now let's say there's a football match that happened a week ago. The scores don't change, the highlights don't change. We don't need to update the data as it passes, as time passes. It's static. That's a case where we can just use HTTP connections to retrieve the data and then just show it to the user. We don't really need to update it. where the resource is highly cacheable. Again, in that football match, the score doesn't change. We can just store that in the cache memory of the browser and make the retrieval process very smooth. Instead of having to retrieve the data again and again from a server, you can just retrieve it from the browser cache. Then safety is critical. HTTP, being a very largely accepted protocol, has a lot of safety measures built into it, which are not available in WebSockets. So if safety is of high, if safety, let's put it here. If safety is of high importance, it would be advisable to use HTTP connections over WebSockets. And error handling is crucial. Again, because the HTTP protocol is so widely accepted, it has a lot of error handling protocols built into it, which are not available in WebSockets. WebSockets rely on the developer to build them using its message layer. The only error WebSocket, the only error handling WebSocket does is when a connection is hindered, not really effective. Similarly, here are some scenarios where WebSockets make a much better choice than HTTP connections. And the user is required to react to change quickly. Let's say you're building a chat application and you want the users to use it, you want the users to reply to each other, to chat with each other. But they could only reply to a message when they know a message has arrived, when they know someone has messaged them. For such cases, we need WebSockets. We cannot do these over HTTP connections. When the user wants on-when updates regarding the state of the resource. Again, let's take the example of the football match. Let's say a football match is going on, it's going on at this very second and your favorite team is playing. You need those updates as they happen. You need to know every goal as it happens. That's when WebSockets are useful. And when there is a high frequency of messages between the client and the server and really small payloads. Again, as the frequency of messages between the client and server rises, even with HTTP and long polling, the latency will rise. And if they have very small payloads, we can use WebSockets instead. Given that the data we're transferring is not really confidential and we're not concerned about safety much. And here's a list of some JavaScript libraries that might help you in your next real-time project. There's Sock.js, WS, Socket.io, Fay WebSocket, Socket Cluster, and a lot more. You can give it a quick search and you will find a lot of these libraries with different use cases, and you can just choose what's best suited for you, what's best suited for your project. Now, although we know that the real-time data transfer is possible using WebSockets, it's still just tip of the iceberg. There's a lot that goes on underneath those applications that we just use. Here we've just taken a quick peek. I hope this video ignites a curiosity within you to Google more about WebSockets and their use cases. Thank you for your time.